What's going on, general math? First lesson of semester 2 for us. So some of us have not taken a general math class with me before, and we kind of do notes together. I'll type them up for you, walk you through them, talk about some examples in class if you're in class, and otherwise you can always go back and watch these videos for further instruction or to kind of hear the lesson again. So first lesson of semester 2, we were talking about number theory, or real numbers, types of numbers. So we have this, it's a really good diagram here. And then there's kind of some definitions or some labels within this diagram. So in this big box, this contains every single number possible, and we call these the real numbers. So real numbers are any number that can be found on a number line. Yeah, and actually, a real number is any number that can be found on a number line. Sorry, we don't talk about imaginary numbers here. So inside these real numbers, we can split it up into two categories. So here on the left, we have rational numbers, and on the right, we have irrational numbers. Now, in the word rational, the root word is ratio, and a ratio can be represented by a fraction. So like I got 4 blue socks compared to 2 red socks, right? So a ratio, that ratio would be 4 to 2, or you could write as a fraction like 4 over 2. So a rational number, notice rational ratio right here, is any number that can be made into a fraction or can be represented by a fraction. So a rational number might actually be a fraction like 2/3. It could also be a decimal that stops, like 0.3, because that could be represented as 3 divided by 10. It could also be a negative decimal that stops, like negative 3.125. Something else that it could be would be a fraction that repeats, something like 0.6666666. That would just be 2/3, right? So if it's a fraction, a decimal that stops, or a decimal that repeats, it's a rational number. Whereas an irrational number, just means like the opposite, or not. So it is not a ratio. It is not a fraction. That would be a decimal that never ends. So pi never ends. It's like 3.124159 ... And it keeps going, it keeps going, it keeps going, and it never repeats. And then another example would just be like the square root of 2. Again, type it into a calculator, plug it in, and that decimal will never stop and never repeat. Inside the rational numbers, we have integers. So integers would be something like -2, -1, 0, 1, 2. It's anything that doesn't have a decimal or a fraction. So like 76 or -89 would be integers. Whole numbers are integers that start at 0. So they would be 0, 1, 2, 3, 4. It's basically all the positive numbers and 0. But again, they don't have decimals and they don't have fractions. And then natural numbers, same idea here, but it's just without 0. So we just start counting at 1. So it's our counting numbers on your hand. 1, 2, 3, 4, 5, 6, 7, all the way up to 1,000,000. Kind of moving on to the second part of this lesson, we have number lines. So number lines are a great way to visualize our real numbers. Notice the picture on the left. I'm talking about this diagram right here, this number line. The numbers -3.1. I don't know why that negative that at all. -3.1 and 2.8 are plotted on this number line. And with the number line, we can see how far away a number is from 0. This is known as the absolute value. So how far away is -3.1 to 0? Well, it's 3.1 units away. So we would say the absolute value, which is represented by these brackets right here, these straight brackets. Absolute value of -3.1 is 3.1. What about the absolute value of 2.8? How far away is it from 0? Well, that's just 2.8 units away from 0. So if you notice, the absolute value just takes away the negative off of any number. So it makes a negative a positive, and it keeps a positive a positive. Another good thing that number lines are useful for is determining which number is greater than the other. So here on this number line, we have negative 1.90 and negative 1.09. For a lot of us, it's really tough to use decimals and to look at decimals and figure out what they're telling us. But if we plot them on a number line, we can figure out which number is bigger than the other. So the number furthest to the right is going to be greater. So we would see that negative 1.09 is further right. So we would say that negative, I don't like how they wrote that backwards. Up here, we would say negative 1.09 is greater than negative 1.90. And notice in this inequality, so this is an inequality sign, the gator, or the inequality sign, right, it wants to eat the bigger number. So it wants to eat the negative 1.09. Now down here, they wrote it backwards. They put the smaller number first, but again, the gator is eating the bigger number. And then just a helpful hint on your homework, if you don't know, sea level is 0 meters or 0 feet, but I think they use meters for their label in the homework. If you have any questions, shoot me an email.